What is styrofoam and why is it used in engineering? Speaking more about engineering, have you ever stopped to think about how many times styrofoam is present in your daily life? Whether it's in the packaging of a new appliance, in the cooler you take to the beach, or even as part of the structure of a building you wouldn't even imagine. This white, lightweight material that seems so simple is actually a quiet giant in modern engineering. Today, let's uncover the secrets behind styrofoam, what it really is, and more importantly, why it has become such an indispensable material in so many areas of engineering. Many of us know styrofoam only by its appearance. Those white beads, compact, easy to break, and that make a mess everywhere. But the truth is that styrofoam goes far beyond that deli tray from the supermarket. It's a material with incredible properties, the result of a lot of materials engineering, and that's why it's such a versatile material. The general perception is that it's a fragile and disposable material, but engineering has been able to see its true potential. But after all, what is styrofoam? And is that the correct technical name? Well, styrofoam is actually a registered trademark for a type of foamed plastic in Brazil. The technical name and what you'll find in most engineering projects is expanded polystyrene, which stands for expanded polystyrene. Imagine that expanded polystyrene is like an inflated plastic. It's made up of about 98% air and only 2% polystyrene, which is a petroleum derivative. It's this unusual combination that gives it its unique characteristics. To understand how something made of so much air can be so useful, we need to understand how it's made. The manufacturing process of expanded polystyrene is fascinating and relatively simple, which helps to understand its properties. It all starts with small polystyrene beads, which look like grains of sugar. These beads contain an expanding agent, usually pentane. When heated with water vapor, these beads expand, increasing up to 50 times their original volume. During this process, the pentane evaporates and is replaced by air, which gets trapped in millions of closed cells inside each bead. These expanded beads are then reheated with steam and molded into giant blocks or specific shapes. That's why styrofoam is so light, because it's basically air encapsulated within a plastic structure. This structure, in turn, gives us several advantages. First, the extreme lightness makes transportation and installation easier, reducing labor and logistics costs. But if it's almost all air, it must be fragile, right? Not exactly. Despite its lightness, the closed cell structure of expanded polystyrene gives it a surprising resistance to compression. Think of the tiny bubbles. They act like miniature shock absorbers, efficiently distributing the load. This is what allows it to be used in structural applications, supporting weight without excessive deformation. Another key property is its excellent thermal insulation. Air, when trapped and unable to circulate, is a poor conductor of heat. Thus, expanded polystyrene becomes an effective barrier against temperature transfer, keeping heat in and cold out. Or, in the case of buildings, preventing external heat from coming in or internal heat from escaping. This same cellular structure also contributes to good acoustic insulation at certain frequencies, helping to absorb sound and reduce reverberation. Although this is not its main application for this purpose, now let's get to the heart of the matter. Why is styrofoam or expanded polystyrene so widely used in engineering? In the construction sector, its applications are diverse and smart. It is used in slabs, especially the ribs, where expanded polystyrene panels are used as filler between the concrete ribs. This drastically reduces the self-weight of the slab, which means less concrete, less steel, and consequently a lighter and more economical foundation for the building. In addition, it contributes to the thermal and acoustic insulation of the building, improving the comfort of the rooms and reducing energy consumption. With climate control in roofs, expanded polystyrene is used in sandwich tiles or as an insulating layer, protecting the structure from thermal variation and extending its lifespan. And did you know that it can even be part of a wall? There are monolithic wall systems where expanded polystyrene panels are coated with mortar, creating lightweight structures. The applications of expanded polystyrene in engineering are not limited to just vertical construction, but also include geotechnics and infrastructure projects. It plays a surprising role. Expanded polystyrene is used as lightweight fill in situations where the foundation soil is very soft and would not support the weight of a conventional earth embankment. Giant blocks of expanded polystyrene are stacked to create embankments for roads, railways, and viaducts, reducing the load on the soil and preventing excessive settlements. It is especially useful in clay and wet soils where the bearing capacity is low. Imagine replacing tons of soil with a material that's mostly air. This application demonstrates the robustness and versatility of expanded polystyrene in complex engineering challenges, where lightness becomes a critical factor for stability. Outside of construction, expanded polystyrene remains fundamental. Its shock-absorbing properties make it an ideal material for packaging, protecting electronics, glass, and fragile products. The trapped air acts like a spring system, dissipating the energy from impacts and protecting the contents. It is also used in thermal boxes for food and medicine, keeping the item hot or cold. However, despite all these advantages, expanded polystyrene also faces challenges, mainly related to its environmental impact. Since it is a petroleum derivative and is not biodegradable, its improper disposal is a serious problem. But many people wonder, but wouldn't recycling be a solution? Yes, recycling is a crucial part of the solution, and technologies for this are advancing, turning expanded polystyrene into other plastic products or even back into raw material. But conscious use and the search for sustainable alternatives are a constant debate in engineering. If you've made it this far and enjoyed the video, take the opportunity to subscribe. If you're not subscribed, leave your like and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be remembered in our videos. To learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description. To gain access to various opportunities to develop a range of skills that will make a difference in your career. Had you ever imagined all these uses for Styrofoam? Do you know any other unusual ways it's used in engineering? Leave it here in the comments because I want to know. On the side, there are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. If you'd like to support us, please like, subscribe, turn on notifications, and consider joining as a channel member. That's all, engineering fans. See you in the next video.